All right, so you should have received back your parent functions chart. We are going to fold that in half. That's going to go in your ISN because we're going to write on the front of it and look at graphing some of these. And you'll have to excuse this writing. It's going to be worse than usual because I'm writing on my tablet. So once you have folded that in half like it's ISN size, this is going on page 112. And you can title the outside of this Trig Parent Functions. All right, and so we're going to draw a circle. I get to cheat just a little bit. It's still not going to be like what I want, but that's okay. So draw yourself a circle. Then let's try and hit the middle here. Close enough. You gotta pretend like that's the middle because I've learned that once I draw it on here, I don't know how to adjust it when I'm not standing at my board. So that's gonna be good enough. So we know that this is starting at 0. As we go around, this would be pi halves. This would be at pi. This would be 3 pi halves. It's a 2. And then around to 2 pi. And then our ordered pairs, we're not going to fill in the whole thing, but we know that this would be at 1, 0. This would be at 0, 1. This is going to be at negative 1, 0, 0, negative 1. Okay, so we're going to have this to refer to as we draw these graphs. Now we're going to do sine, cosine, and tangent, so just kind of space out what you have left there. I'm going to have to scroll up and down so you can see what I'm trying to get at here. So we're going to start with y equals sine x. Okay. We have this. We know that with our ordered pairs, it's always going to be cosine x, sine x, or theta. We'll talk about how those get used a little bit differently than each other in just a minute, but whether it's theta or x. So the x value is always your cosine, the sine is always your y value, and when you're talking unit circle. Okay, so the greatest value you can have for sine or cosine when we're talking about the unit circle, which gives us our parent function, is going to be 1, okay, because it increases or decreases depending on what's going on. So if you think about what we started with here, cosine starts at 1, sine starts at 0, and then the y value gets greater and greater and greater. This is the greatest y value we have. And then it starts to decrease again, keeps decreasing, and then it starts increasing again. Well, the same thing is happening with this graph. Oh, dang it. Grabbed the wrong thing here. Well, I'm not even sure how to fix that. There we go. So we're going all the way around the unit circle. So we're going to go from 0 here to 2 pi. Right, that's on along our x because we're going around, and our y's, our range goes from negative 1 to 1. Now we know that this function is going to repeat, but this is as far as we're going to go on the axis. So halfway, this is where I totally messed it up earlier the other day, half of 2 pi is pi, and then this gives me pi halves and 3 pi halves. I would like it if I could have written that a little bit smaller. Have trouble writing small with this stupid stylus. Okay. So what we know when our angle is 0 right here, our y value or our sine value here is also 0. Oh my gosh, I'm grabbing the wrong thing again. Oh, goodness gracious. Well, how can I scroll? Why can't I scroll? Oh my goodness. Okay, I cannot grab. There we go. I'm probably not going to be able to scroll up and down, so you're going to have to look at that circle. So when my angle value is 0, my sine value is 0. Why can't I? Trying to make a point there, it doesn't let me like draw. Ugh. Okay. So then when I'm at pi halves, my sine value is 1. Currently all I can do is a dot. Then when I go around to pi, my sine value is 0 again. Okay. Oh, goodness gracious. Okay, I'm gonna make a bunch of points there so I can make it bigger. I can't like draw a dot. What the heck? All right, so then when I go around to 3 pi halves, I'm at -1. And then when I make it back around to 2 pi, I'm back at 0. So that shows you what's happening. And like I said, when we start here, your y value is increasing. So it's increasing to here, then it starts decreasing, keeps decreasing, and then increases back up. Okay, so that's one cycle of the sine function, and then it's going to repeat as you keep going around the circle. The same thing would happen over and over and over again. So one cycle, it takes from 0 to 2 pi to have one cycle of the graph. So what that is called from 0 to 2 pi, that is the period. Okay, we're going to talk about this terminology here when we get to the actual notes, but I want to go ahead and look at this all at once here. So there is sine. Now we're going to look at the same thing with cosine. So now we're going to look at y equals cosine x. And we're going to need 3 of these graphs to make sure you have enough room to get them all on there. So again, we're going to go from 0 to 2 pi. Eyeball it here. Put that at pi. That at pi halves. That at 3 pi halves. Okay. So that's going to give me 1 and -1. All right, so when you look at your x values, when your angle is 0, your x value or your cosine value is at 1. When you are at pi halves, it's at 0. Pi is -1. 3 pi halves is 0. And then at 2 pi, you're back at 1. So that's where you get the shape of the cosine function. But a whole lot better than that. I could do better with a pencil or at my board, but doing the best I can with the stylus. All right, so then we're going to look at tangent. So now y equals tangent x. So now remember that tangent of x is equal to sine x over cosine x. And so we're going to do the same thing. We're going to go from 0 to 2 pi. Probably shouldn't have made that so big there. 2 pi. Here we are at pi halves, and 3 pi halves. Okay, we can go ahead and make 1 and -1. All right. So when our angle is 0, our tangent value is sine over cosine. Well, at 0, sine is 0, cosine is 1, which means tangent is 0. Okay, at pi halves, sine is 1, cosine is 0, so that gives us 1 over 0, which is undefined. So this actually is an asymptote. Then back at pi, we've got 0 over -1, so we're back at 0. Then at 3 pi halves, we're going to be undefined again. And then we're going to be back at 0. Okay, so that doesn't give us a great shape. Now we've already graphed it, so you have an idea that it looks kind of cubic-y, an odd function shape, whether it's this or this. You've got to make sure that you understand what's happening here. So let's think about this. When you look at, and you can look back up at your circles, but let me just talk here. We talk about what's positive and negative. Quadrant 1, all of them are positive. Then sine, tangent, cosine, right? So from 0 to pi halves, everything's positive. So from 0 to pi halves, your tangent function is positive, which means it is increasing right here, which that's what would be happening when you're making this fraction. And we've got an asymptote, so we've got an arrow up like that. So then in quadrant 2, or from pi halves to pi, which is right here, your tangent is negative. So since tangent is negative, it's coming up like this. Then tangent is positive in the third quadrant, or from pi to 3 pi halves. So it's coming up like this. Then it's negative here again, and it's coming up like this. Oh gosh, but a whole lot better. So this shape right here is what repeats, because then now I'm back around here. If I started over, I would continue it up like this. I don't know if you can tell what I'm just pointing or not, because I don't know. But if I went past 2 pi, it's going to look like this. So this is the shape that repeats over and over and over again. When you look back up here, we talked about, for this one, the period is 2 pi, because that's what happens and then it repeats. So same thing for cosine. Starts here, comes back up to here, and then it's going to repeat. So our period here, that's an R, period, is 2 pi. Well, here, for tangent, this is the part that repeats. So it's not a whole 2 pi that I need to just get one cycle. One cycle just goes from pi halves to 3 pi halves. So a period for tangent is just pi. Okay, you only have to have a domain of pi to get the function that repeats. Okay, that's how you can sketch these just from understanding what's happening with your unit circle to get the idea of what your key points are and what your shape is like. Okay, so now grab your other set of notes. Let's talk through some vocabulary. This is going on page 113 when we're done. Okay. So we looked the other day at the fact that sine and cosine are like good friends. They follow each other exactly, pi halves, radians, or 90 degrees apart. So it is just a horizontal shift to get from one to the other. Okay, just a horizontal shift there. So other words for these graphs, we can have what is called a sine wave. Oh, again, you have to excuse this crazy handwriting when I try and write these lines. Or sinusoid. Okay, a sine wave or sinusoid is the graph of a sine function in trigonometry. Okay, so a sinusoid, or sinusoidal functions is another kind of form of that word, is any curve that can be written in this form. Okay, so it's, even though sinusoid makes it sound like it's just sine, it's really any of them that can be written in that form. And so we know that we can write cosine that way because it's just a horizontal shift. So any cosine function can also be written as a sine function. So this just shows with all the transformations that we'll talk about in a minute. Since the cosine function is identical to the sine function except for a horizontal shift of 90 degrees or pi halves radians. So a cosine of x is the same as sine of x plus pi halves. So here are the transformations that happen, and we're going to talk through each one of these. So this right here, these are the same a, b, c, and d that we use when we transformed other functions. They do have some different terminologies for them for trig functions, though. This here, which is normally what we look at, is our vertical stretch or compression, is the amplitude. It still works the same, it just has a different name. And it's the absolute value of it, because the sign there, if it was to be negative, that would show a reflection. The b here, which we're always going to factor out if necessary, is the number of cycles from 0 to 2 pi, or the frequency. So this right here represented our horizontal stretch or compression. So if you think about taking one of these waves, and if you were to compress it, do a horizontal compression, and you squished it together more, then it's going to repeat more often between 0 and 2 pi. So how many cycles would you go through is what that's looking at. And then the period, your normal period for a parent function of sine and cosine is 2 pi. So to figure out what the actual period is, if there is a horizontal stretch or compression, you would take that normal period and divide by the absolute value of b. But we just looked at on the other page that your normal period for tangent is pi. It's not 2 pi like sine and cosine. Then c here, that is your horizontal shift, just like it was for the other functions that we looked at, which is it's also called a phase shift for your trig functions. And then d is still your vertical shift, sometimes also called displacement. Okay, so functions that repeat infinitely, which these do, are called periodic functions. Okay, they're periodic because they have periods that repeat. Okay. So the first thing we're going to look at is the amplitude, right? And hopefully this stuff copied well for you, but your amplitude is the A, right? It is always positive. Okay, I switched from just my stylus to the actual pen that came with these tablets because I can point better with it, but I can't ever make circles. I don't know why. So it's always positive. So the amplitude, when you're looking at the actual function, this is the absolute value of the little a. Okay, so, and that is the coefficient. Oh, sorry. I was looking for my, oh, dang it. Holy crap. There we go. I'm going to try that other stylus again. The absolute value of the coefficient of sine of x or cosine of x. So your amplitude here, if we look at y equals 2 times the sine of x, it's the absolute value of that coefficient there. So the absolute value of 2 is just 2. Okay. If we go to graph this, now let's just look parent function first. Make that a 1 and negative 1. We're going to graph the parent function with like a dotted line. So there's your other pieces there. I'm not going to label them in there because I know it's kind of small. But we know that the parent function for sine, we've got a 0 there. Oh, look, I can make dots when I use the real pen. And then, so here's the parent function. All right. But when you have the amplitude, okay, it says it only applies, so now it only applies to sine of x and cosine of x. Okay, and that's what we're doing here. We dotted our little parent function for sine of x. And right now our vertical distance from the midline, which happens to be the axis, to the maximum, that's just 1. And the distance here is 1. but the actual amplitude, because this is the parent function, this is not, it is half the vertical distance of the graph. Okay, so the vertical distance, we go from -1 to 1. So right now, it's just, that's a distance of 2. So the amplitude of the parent function is 1. But this is supposed to be 2. And it's also the distance from the midline to a minimum or maximum point. All right, so that's the amplitude. It's supposed to be the distance from here to a min or max. So when I go to graph the actual one, since this is, instead of just 1, it's going to be at 2, just like it would be for a vertical stretch or compression. These points here at 0 stay 0, so it's going to look like this. So it acts like a vertical stretch or compression. We just have to have a few different key points in here because some other things happen with the trig. All right, so now when I look at cosine, if I want to come in here and get my parent function sketched in, the amplitude, so right here, this is like a 1. So the absolute value of -1 is 1. So the amplitude doesn't change, but this is negative, which actually gives us a reflection. Remember, that would be a reflection in the x-axis. So to look at my parent function, let me get that in there. We're going from 0 to 2 pi. We'll get those key points in there. So for cosine, I'm starting here at 1. Right? It goes through 0. This would be at -1, 0, and back up here at 1. So to just make a dotted version of my parent function, which sounds a whole lot easier than it is, there's my parent function. Now, there's not actually a stretch or compression because the amplitude is 1. However, since this is negative, it is a reflection, so the actual graph of the function would look like this. But better, always better. Okay, so amplitude, you treat it like your vertical stretch or compression. So now we look at the period. Okay, and before we do that, let's talk about the difference between the x and the theta. Officially, there is no difference. Whether I'm talking radians or degrees, I could use x, I could use theta. There is no set rule for either one. But for general purposes, so it's not confusing when something comes up and you're not sure, sorry, I gotta stop turning them. You're not sure if you're supposed to use it. Sometimes it doesn't matter, but sometimes it matters. If you're supposed to divide and use 2 pi or 360, you got to know whether or not you're using degrees or not. And if there's not a phase shift or something that's obvious in there, you may not really know which one you're using. So just for purposes of making things easier, if you see an x, that means we're going to use radians. And if you see theta, that means we're using degrees. But remember, that's not like an official rule. Oh my gosh. Sorry, I keep switching between the pens. I can't write with either one of these things. I can't erase apparently either. Okay. Degrees. Yeesh. All right. So, but it, a problem, if it was a word problem and it's talked about theta, but then it was clearly using radians, I mean, that's okay because this isn't a rule that, anybody's made up or anything. But what we did learn from writing and graphing our parent functions on another piece of paper is that when you do sine of x, your period, okay, so let's talk about what these are here. First of all, they're always positive. Okay, you can't have a negative period. It is the horizontal distance needed to show one cycle. Oh my goodness. Why can't I write? Cycle of the graph, right? So you're going to divide to figure it out. So this is one cycle of the graph right here if we're looking like at a cosine. There's your amplitude. Or it could go from here to here if we're talking sine. One cycle. You're going to divide the normal period, because it could be something different depending on which one we're talking about. So let's look at what that means. We know for sine and cosine that if we're using radians, the normal period was 2 pi. But for tangent, it was only pi. So that's why I can't just put a value there. Okay, sorry, my phone rang. I have no idea what the last thing I said was, but the periods from sine x and cosine x, those are both 2 pi. Tangent of x, it's just pi. That's why I can't put just a value down here. Plus, if we're talking degrees, then that 2 pi is really 360. And the pi is really 180. Okay, so you are going to divide the normal period, whatever it may be for however you're doing this, by the coefficient of x or theta, depending on which one you're using. And that coefficient is really b. Okay, that's me trying to put b in quotes right there. So it's the b that comes right in front of x or theta. Okay, so we'll look at what in the heck I'm even trying to say by that. This is your b. It's right before x. This is not right before theta, but that would be like 1/2 times theta. And then right there we have a 3. So in order to find the period here, you're going to take, since this is an x, that means we're using 2 pi. We're going to divide it by this coefficient, which is 2, which means the period, oh my gosh. Sorry that I just sneezed at you, but I don't have time to keep redoing this. So I've got to just get this done. So my period is just pi. Oh my god. Look, by the time I get back, you'll probably all down at the counselor's office begging for a new teacher. All right, pi. My period is pi. Here, remember this is cosine of like 1/2 theta. Well, we're using theta, which it means is degrees. So we're going to take 360, because that's our normal period for cosine, and we're going to divide it by this coefficient, which is 1/2. So when you take 360 and you divide it by 1/2, it's like multiplying by the reciprocal. So that's 360 times 2, which is 720 degrees. So it got stretched out. And then here, tangent. Now our normal period for tangent, and x means we're using radians, is just pi, not 2 pi. We divide it by the 3, so our period is pi thirds. Pi thirds. There we go. There's our periods. Okay, so your phase shift, which is your horizontal shift, left or right. It is the c part of your function. It is the horizontal translation of the graph. So we're shifting it left or right. It shows how far and what direction. Okay, so shifting it left and right, just like you're used to with the other parent functions. And the examples are at the top of the next page. All right, so here, remember this is, the horizontal shift is whatever is happening, being added or subtracted to the x, and there's nothing happening here. So your phase shift on that one is just none. Here, this is x minus c. There's no b in here. If there is, we have to take that into account. But you also have to remember that it is x minus c. Remember, whatever's happening with x, x is the liar. It's always the opposite. So since it looks like a minus, it's actually a positive pi eighths. And since it's positive, that tells you that you go to the right. Okay, so your phase shift is a positive pi eighths. Here, this is, we factor that out, and this is a positive here, which means this is really minus pi. There was nothing to factor out. So it's a negative pi, which means we go to the left. But it's not like we write left pi. The phase shift is negative pi, and then you just have to know what that negative means. We go to the left. All right, so here, this one we have to actually, we have a B and a C in this one. So in order to make this work out nicely, we have to factor this out. So this is going to become y equals the tangent. And I have to factor the B out, factor the 2 out. This becomes x plus 3, which means my phase shift is a negative 3. Also, since it's negative, it means I'm going to the left. All right. So then we have a vertical shift. So our vertical shift is our D. And this is just what it sounds like. It is the vertical translation of the graph, shifting it up and down just like you're used to with the other parent functions. Okay, so all together now. We can have all of them in one equation, so we're going to just look at them again. We looked at these quickly at the beginning, but we hadn't talked about them yet. So the A that comes here in the front, this is the amplitude. Okay, the absolute value of the A is the amplitude. It's like your vertical stretch or compression. Then you have the trig part of it, which this really could be sine, cosine, or tangent. And then the B, you always factor it out if there is a C. If there's something after the X or the theta, you need to factor that out. So this all works out nicely for you. The B is how many cycles. Usually that's not something that you're necessarily asked. It is something that's good for you to understand so you know what's going on with the graph. But we're going to use that B to figure out the period. So you take 2 pi over the absolute value of B, or it could be 360. And then tangent's a little bit different here. To figure out what the period is, that's the part that we're normally more concerned with, is how far, how long does it take before it repeats. Then after B is factored out, that's super important. Then what you have in here is your C, that's your horizontal shift. It's called a phase shift for the trig stuff, but it works as your horizontal shift that you're used to. And then D is your vertical shift or your displacement. So let's look at what we have here. We have y equals 2 sine of 4x minus 2 plus 3. So before we think about anything, we need to let's go ahead and factor this out. So this is going to be equal to, okay, the 2 is just the 2 times the sine of, so I have to factor the b out. 4 times x minus, well, 2 divided by 4, it's going to give me 1/2 in there. And then close both of those parentheses, plus 3. Now I have it how I need to actually look at it. So your amplitude, that's going to be your absolute value of this coefficient. So your absolute value of a positive 2 is just 2. Your period, remember 4 is the number of cycles, but we want to find the period. We know here that this is an x, so we're using radians. So my normal period for sine is 2 pi. I'm going to divide that by the absolute value of b, because remember, if this is a negative, that's going to be a reflection in the y-axis. It's not actually it doesn't have anything to do with the period itself. I take that and I divide it by 4. So 2 pi over 4 is just pi halves for the period. Your phase shift is going to be, remember, it's the opposite. Okay, just like here, this is a 4. This would actually be a horizontal compression. That's why the period is so much smaller. You have 4 cycles happening in a 2 pi span there. But this is going to be a positive 1/2. Your phase shift is your horizontal shift. And then your vertical shift is a positive 3. And this is what the graph here would look like. Okay, and what's happening with your period and your phase shift and whatnot. Okay, so just looking at this, identifying, then you should be able to work backwards. Also, if you were given these things, you should be able to take these and adjust them to put them into an equation. Okay, so clearly I will not be there for tutorials today. If you have any questions about this, Ms. Tremont is available, Ms. Archer is available, Ms. Rice is available. Go to them maybe for MAV time if you needed to, or for tutorials if you need something today, or if perhaps none of this made any sense. But I will clear it up obviously when I get back as well. I just want to make sure that you at least don't get too terribly far behind. So, do the best you can on this, and I will see you when I get back.